Hello. So today we're talking about identifying triangles, which is code for identifying angles and sides of triangles and corresponding parts. So let's highlight those angles and sides. We know what angles and sides are. The word corresponding, that's what I want to focus on here. Corresponding, every time you see that word, I want you to think matching parts. So corresponding parts means matching parts. Okay. When we get in, as we're getting into this, there's a couple extra geometry things that we haven't super talked about yet that we need to know just for today. So follow along and fill in the blanks with me. Dilation is a type of transformation that changes the size of a figure. So if I've got a triangle over here, if I change the size of it, I can make it bigger or I can make it even smaller. Dilations can do both. They can make them bigger or make them smaller. We haven't talked about them yet because Unit 1 was all about rigid transformations. Ones that doing things to shapes that didn't change the shape or the size. Okay. Corresponding parts refers to either a side or angle in the same spot on two different shapes. So we can have matching sides and we can have matching angles. I'm going to add that we can also have matching points. Okay, or matching vertexes. Okay. Corresponding parts can show up in two different ways: congruence and similar. So congruence is when everything is the same shape and same size. Okay. When they're congruent, everything has to be the same. So that's same measures. If two sides of a triangle match, they both need to be 5 feet or 3 inches or whatever. Okay, they need to be the same. Figures are congruent when rigid transformations were used. So that's your translations and reflections and rotations, things we talked about in Unit 1. Okay. Figures that are not congruent use non-rigid transformations. That is our new one today, dilation. Okay, similar figures have the same shape. So can both be triangles, can both be rectangles, can both be stars, okay? But they are different sizes. So dilations create similar figures. Translations, reflections, rotations, they create congruent figures. Okay, so that's a little bit about dilations and that kind of stuff. Symbols that you need to know. So over here we're going to draw a little triangle. Here's my triangle ABC. If I want to talk about triangle ABC, this is what it's going to look like on Delta Math. There's going to be a triangle symbol. It'll look like this. Okay, it's just a triangle in the text. And the triangle that I'm talking about is ABC, so I would put triangle ABC. If I wanted to talk about a particular angle, there's my symbol. And if I want to talk about angle B, I'd put angle B with this symbol. If I want to say that two things are congruent, I've got an equal sign with a squiggly on top. That is the symbol for congruent. And lastly, if I want to talk about a particular side of the shape, so if I wanted to talk about angle B, I would use this symbol for angle B. But if I want to talk about the side A to B, then I would write it like so, A to B with the line on top. Okay. Triangle congruence. Triangles are congruent if all three angles and sides are congruent. Corresponding parts of triangles are the parts that match. So remember, the word corresponding, always think what matches, okay? When stating that triangles are congruent, you must write the letters in the same order, okay? Let's just practice a little bit what your homework might look like. If I'm saying triangle RST, so we're going to draw a triangle and we're going to put R, S, and T. If triangle RST is congruent to triangle X, Y, Z, then without even drawing a picture, I know that R and X are going to go together, S and Y are going to go together, T and Z are going to go together because they are in the same order as it was written. But with that, I can answer anything that Delta Math could possibly throw at me with this triangle. So if Delta Math asked me to find what is corresponding with angle S, well, I'd be able to say angle Y. Okay, if R to T was what I was being asked about, I would be able to say X to Z. Okay, so again, we're just looking for what matches. We're not going to see just triangles on our homework, so let's flip the page and see what it's going to look like. Okay, first of all, these do not make it onto your homework, so put an X through them. We're just looking at the ones with pictures. Okay, figure 1 and 2 are congruent. Which point corresponds with point A? So I see point A right there. And my thought is A is connected to the two longest sides of the shape. So I'm going to find the two longest sides, and I see that A would match up with I. Some people can just look at it and tell. Some people have to rationalize it for themselves. You figure out what works best for you. Okay? Take a look at this one. This one's a little tricky. This one is asking us to find which side corresponds with X to W. There's XW. I see that XW has the exact same slant as N to O. And I also see that XW is the shorter, longer side. So VY would end up going with M and P because they're the longest. So N and O would have to be the one corresponding with XW. Lastly, we're going to fill in the blanks and then find the side that corresponds with WX. So the two figures are not congruent because they're not the same size, right? Congruent means same shape, same size, but they're not the same size because a dilation was used. Or a dilation is also called a non-rigid motion. And lastly, the side that corresponds with W to X. See, I see G to E or E to G. Delta Math is not particular about what goes first. Okay, so don't worry about it. I think it's G to E because the slant is the same, the proportions are the same. So you'll notice if we wanted to count the slope, my slope is 1/3. My slope here is also 1/3. Okay, and I see that these two are flat, so they have to go together. Whereas G and E, W and X are both slanted, but not the longer sides. They're the two shorter sides. So, like I said, some people can just see it. Some people need a little bit of rationale. Please try the homework and email me if you have any questions. Thank you.